Hey everyone, today we're going to take a look at rewriting some trig expressions as a single ratio. Now, one thing I do want to make real clear real quick right off the bat, if you're coming here, look at this problem, example 5, there is a typo. This should not be cosecant, it should be cosine of x, which makes a little difference. So, coming back up here, example 1 says, we got the secant of theta times the cosecant of theta minus the tangent of theta. So the first thing I'm kind of jumping to here is realizing like none of this necessarily is going to do anything special with each other. Secant and cosecant are not reciprocals of each other. So really what this leads me to is very quickly noting that I'm going to have to rewrite this as sine and cosine so I can actually compare them with each other. So I know that secant can be rewritten as 1 over cosine of theta multiplied by, and we can rewrite cosecant as 1 over, oh, that was weird, 1 over sine of theta. And again, you can see really clearly from that. If I multiply those together, nothing's going to happen. 1 times 1 is going to be 1. And in that denominator, cosine times sine is just cosine theta, sine of theta. So nothing simplifies or cancels. What that means, though, is I can now bring this tangent of theta down, which we know is sine over cosine. So now I have two fractions that are being subtracted from each other. Now, one thing to be aware of, some people try to do this right here. They'll get to this step and be like, oh, I can cancel this sign and this sign out with each other. But that's not allowed unless this operation in the middle is multiplication. Since this operation is subtraction, this is not allowed and we can't do that. We have to figure out how to combine those into a single fraction first. So I'm going to look at my denominators. In this side, I've got a denominator of cosine times sine. This side only has cosine though. So it's missing a sign. So I'm going to multiply this right side by sine of theta on the top and the bottom. With that, now I have two fractions that both have cosine of theta times sine of theta as their denominator. So now I can just rewrite the numerators as their problem, right? This cosine of theta, sine of theta is down here on both cases. Now I'm just going to rewrite the top as 1 minus sine times sine, or in other words, we could call that sine squared. So 1 minus sine squared of theta. Well, I also see now that we've got an identity going on here, right? 1 minus sine squared is one of our Pythagorean identities. 1 minus sine squared is the same thing as cosine squared of theta. Still have this cosine sign on the bottom. And now I've got cosine squared on top and 1 cosine on the bottom. In other words, I have 2 cosines on top and 1 cosine on the bottom. So in that numerator, I can cancel out one of these cosines with this cosine on the bottom, which means I'm left with 1 cosine on top and the sine on the bottom. And cosine over sine becomes cotangent of theta. And that is our final answer for that one. All right, in our second example, this one has a fraction starting it off right in the beginning that we've got to work with. So again, very similar to this last one, the very first thing that I'm going to think about doing is I'm going to see what happens if I get this in terms of sine and cosine. Because again, secant and cosecant are reciprocals of sine and cosine. And then the tangent has nothing to do with either of them. So we need to figure out how we can bring this together in a different way. So what I'm going to start by doing is I'm going to rewrite the secant as 1 over cosine of x. And I'm going to rewrite that cosecant as 1 over sine of x. And in that denominator, let me do this tangent first. I'm going to write the tangent as sine of x over cosine of x. And so what I know is in the beginning, I have this 1. But if I just write it as 1, it's kind of weird because you've got a whole number added to a fraction. What would make more sense is to take this 1 and write it as a fraction 1 over 1. So I took this 1 and also made it a fraction, meaning now I can think about these denominators and what would make a common denominator here. So in this case, it's kind of weird, starting with the top one here. This cosine and this sine are my denominators, and there's no way to turn these into each other. So if I want to find a common denominator, I need to multiply by the opposite one. In other words, this cosine, I need to bring this sine and multiply it here and here. Multiply at the top and the bottom. And that's going to give me a common denominator of sine cosine. Likewise, this one's now missing the cosine. So I'm going to bring this cosine over here and multiply it to the top and the bottom, which would then give it a common denominator of sine, cosine. So you're essentially bringing each opposite denominator to the other side. So this sine of x comes over here, and this cosine of x comes over here. Similar idea on the bottom, except we've got a 1 on the bottom. So really all we need to do is bring the cosine over here, right? If I multiply both sides, the left side by cosine, that's going to give me a common denominator that I can actually work with. So in the top of this fraction, we knew that we had sine, cosine on the bottom. And in that numerator, I've now got sine times 1 plus 1 times cosine. In other words, this is going to become sine plus cosine in the top. Sine plus cosine. And in that denominator, cosine times 1 is going to give me cosine over cosine, which then gives them a common denominator of cosine. And then we're going to have cosine times 1 plus sine, or cosine plus sine. Now, one thing I do want to kind of point out while we're here. Some people might look at this top part right here and be like, oh, hey, this sine and this sine can cancel, and this cosine can cancel. That would be okay if that was a multiplication. But since this is addition right here, that doesn't work. You cannot do this unless it's multiplication completely on the top or the bottom. So keep that in mind. But at this point, I do have a fraction divided by a fraction. So in this case, I know I can do my keep, change, flip. I'm going to keep the bottom the same. Keep the top the same. So sine of x plus cosine of x all over sine x, cosine x. Multiply, and then take the reciprocal of this to multiply it here. So that means cosine of x goes on top, and the denominator becomes cosine of x plus sine of x. Now, one thing to be mindful of is when you do this, when you have fractions like this, technically this fraction is in parentheses with its top and its bottom. And this numerator right here is in parentheses, and this denominator is in parentheses. This is where you can cancel with addition. You can cancel with addition as long as the entire addition problem gets canceled. So in this case, sine plus cosine can cancel with x, cosine plus sine, because essentially if you just flip the sine plus cosine, you'd get the same thing. So sine plus cosine does get to cancel out. So that leaves us with cosine on top over sine x, cosine x on the bottom. And I can see there's something else that cancels this cosine cancel. And I end up with 1 over sine, which is the same thing as cosecant of x. All right, example 3. Example 3, one of the things that immediately stood out to me in example 3 is you've got sine of x in the denominator here and cosecant of x in the denominator here. We know that those two things represent reciprocals. In other words, we know that if you take sine of x and multiply it by cosecant of x, since they're reciprocals, you have to get 1. That is the property of being a reciprocal. So when I go ahead and do this, we're going to do kind of like we did up in this last problem where we did this step right here, where we took this fraction that had two different denominators and brought this denominator over here and this denominator over here. We're going to do that exact same thing here. We're going to take this cosecant and bring it over here and bring this sine over to here. So let's look what that looks like. So here I'm going to multiply cosecant of x on this side. And on this side, I'm going to multiply sine of x and sine of x. All right. So what that's going to give us is in that denominator, I've got cosecant of x times sine of x. And in that numerator, I've got cosecant of x, secant of x. For the first part, that's this piece right here, minus, and then we got the second part, secant times sine. So minus secant x times sine of x. All right, so what we know then, what is really nice about this is this property right here. If you take a reciprocal and multiply it by its reciprocal, you get 1. Cosecant and sine are reciprocals. So when I multiply these together, this is going to just give me 1. That whole thing goes away, and you just have 1 on the denominator. And anytime you have a fraction over 1, it's just the top of the fraction. So in other words, this entire bottom part right here, all of that goes away. And all that's left is just what's on top up here. So I end up with this just being cosecant of x times the secant of x minus the secant of x times the sine of x. And now what you might notice is that this has a secant and this has a secant. They both have secants, which is great, except you can't just cancel them, right? Even though it's minus secant here, you can't just go cancel, cancel. That doesn't work because, again, it's not just secant. You have a multiplication that's happening first here. But just like with our polynomials that we've worked with before, you could factor things out here. Since this has a secant of x right here and this has a secant of x here, we could factor that out. So it becomes outside the parentheses, meaning that in that first spot, when I take the secant away, all I'm left with is cosecant of x. Likewise, over here, when I take out the secant from here, all that's left is the sine of x. So we're going to have our minus sine of x. Again, being that if you did distribute this back in, it would go back up to where we came from. It would turn back into that last problem. So it's still okay. Now I'm noting, though, what's left in the parentheses, cosecant and sine are reciprocals. Now, there is a minus between them, so they're not necessarily just going to cancel each other, but at least I can change them to the same fraction. So we have secant on the outside still. On the inside, cosecant becomes 1 over sine minus sine of x. Now, again, I have a situation where I have a fraction. Let me actually take that parenthesis off. I have a fraction subtracting something that's not a fraction, so I want to turn that also into a fraction. So I'm going to put this over 1. That way you've got a fraction subtracting or adding a fraction. We always want it to be like that, where you have fractions working with fractions. Well, since the common denominator here is that this has a sign on the bottom, I need this to have a sign on the bottom. So I'm going to multiply by sine on the top and the bottom here. So taking a look what that's going to get us to then, this secant of x is still on the outside. I have this 1 over sine of x minus sine squared of x over sine of x. That came from that multiplication at the end. And I can bring that together now. Secant of x times, I got the sine of x on the bottom. And on top we have 1 minus sine squared. Well, we know that 1 minus sine squared, that is one of our Pythagorean identities. So we're going to end up with cosine squared. So also, I think there's a couple changes then. This secant doesn't really fit into this problem anymore. I probably need to change this into its sine or cosine as well. So I'm going to change that secant into 1 over cosine of x. And then again, inside, that numerator now becomes cosine squared of x over sine of x. Again, noting that 1 minus sine squared becomes cosine squared. I know I did 2 steps at once. I also changed the secant into 1 over cosine there. And I did that, and you can see why now. I've got some stuff that cancels. This cosine of x gets to cancel with one of these cosine of x's up here. So now I'm left with just 1 cosine x on top over a sine x on the bottom. And cosine over sine does become cotangent. All right, and on example 4. Example 4, one of the things I want you to kind of know is if you tried messing with this bottom part right here, for example, we know sine squared is equal to 1 minus cosine squared of theta, and I know secant squared is 1 plus tangent squared of theta. If I change those into those things, that is way more complicated than how it started. Don't do that. Don't make things more complicated. We're going to leave this bottom just the same for now. We'll come back to that in a minute. What I definitely see that I could mess with is this top part. Secant minus cosine. Considering that secant is the reciprocal of cosine, there are some definite changes I can do to this top part right here. So 1 over cosine is secant minus cosine. In fact, we just did this in example 3. We know we could rewrite this as cosine over 1 and then multiply cosine to the top and the bottom. So I end up with 1 over cosine minus cosine squared over cosine, or in other words, that becomes 1 minus cosine squared on top over the cosine on the bottom, and 1 minus cosine squared is a Pythagorean identity, sine squared, so sine squared of theta over cosine of theta. So what I know now is this represents this top part here. So let's rewrite this fraction with that on top. So this now comes down here, and now we have sine squared of theta over cosine of theta divided by sine squared of theta times the secant squared of theta. And again, if you have a fraction and a fraction, don't be afraid to turn things that aren't currently fractions into fractions. So here I could definitely turn this into a fraction so that now I have a situation where I have a fraction divided by a fraction, and I can do keep, change, flip. So I'm going to keep that top part, sine squared over cosine, the same. Change to multiplication. I'm going to do the reciprocal of that denominator. So I'm going to put the 1 on top and the sine squared, secant squared on the bottom. So in this case, the sine squareds get to cancel out, and I'm ultimately just left with 1 over cosine of theta, secant squared of theta. Cosine of theta, secant squared of theta multiplied together. And I think I see another thing that's going to happen here, right? If we rewrote this out, so cosine times secant times secant. So instead of putting secant squared, if we just put secant times secant, we know that a cosine times a secant are reciprocals, so they're going to multiply together and give us 1. So that cosine and that secant, because they're reciprocals, cancel out. And I'm left with 1 over secant of theta, which we know becomes cosine of theta. All right, and on to this last example. Again, noting that this example did have a typo, so please make sure you make that small adjustment. What I can see, let me take a drink real quick. What I can see here is that first fraction has secants in it, but the second fraction has cosines in it. I like cosines. I like being in terms of cosine, and that's a good spot to be in. These secants seem to be the problem. So let's start by only focusing on this first fraction. Let's edit this first fraction down. 1 plus 1 over cosine. And the reason I'm doing this is sometimes it's easier to work with one fraction at a time than both of them. Don't try to overwhelm yourself and do the whole thing at once. If you've got little chunks you could work on those little chunks and see what happens. All right, this becomes 1 over cosine minus 1. And overall, what I know is I'm going to change these into fractions. So this 1 becomes 1 over 1. This 1 becomes 1 over 1. And then I can think about what I got to multiply them by. So on the top, this one has a cosine at the bottom, so I need to multiply that by cosine so that I can work with them. Likewise on the bottom, same thing, just on the other side. I need to multiply cosine to both those ones. And so what I end up getting is cosine plus 1 over cosine, all divided by 1 minus cosine, all over cosine. I know I keep leaving the variable off. You don't necessarily need to do it until you get to the end. Again, what I'm doing here, though, this is my cosine that's on the bottom here. And then I did cosine plus 1. Cosine plus 1. On this bottom one here, cosine is on the bottom. So I put that on the bottom. And then it's 1 minus cosine, 1 minus cosine. Now I can go ahead and do that keep, change, flip. So I'm going to keep the top one the same. And I'm going to move this up and do the reciprocal. So cosine of x goes on top. 1 minus cosine of x goes on the bottom. So I know that this cosine x is going to cancel with this cosine x. And I now know that this new fraction here comes out to be, put that up there, cosine of x plus 1 over 1 minus cosine of x. Still kind of ugly, but now this whole fraction became this, meaning now they're using the same trig function. So this is now here. I still got this plus part that I got to add on here. So plus 1 plus cosine of x over cosine of x minus 1. And what I see here is that these denominators are really similar. I can almost bring these together, except this has a positive 1 and this has a negative 1. This has a negative cosine, this has a positive cosine, and I don't want that. I need them to have the same. So let's make a small change here. I'm going to keep this first fraction the same, cosine of x plus 1 over 1 minus cosine of x plus, and I'm going to do a little factoring here. I'm going to factor a negative 1 out, meaning this top's going to stay the same, 1 plus cosine of x, and this denominator, I'm going to factor out a negative 1. So I'm going to put a negative 1 in front, and I'm going to do a little rearranging, meaning this negative 1, when I factor out a negative 1, it's going to become a positive 1. And this cosine of x, when I factor out this negative 1, becomes negative cosine of x. Meaning that now this and this are the same, we just got this little -1, which we are allowed to move up top because -1 moving up top or the bottom doesn't change anything. So ultimately now I've got this. Denominator becomes 1 minus cosine x. This, like I said, is going to move up here, which means, let me do it like that, which means when I distribute it here, we're going to get -1 and negative cosine of x. So we've got this first part, cosine of x plus 1 plus -1 minus cosine of x. And you can see what's going to happen here. Cosine of x and negative cosine of x cancel. 1 and -1 cancel, meaning everything on the top canceled out. So now there is a 0 left on top because it all subtracted to give us 0. And 0 divided by anything, it doesn't matter what I get on the bottom, anything that has 0 on top gives us 0 as a solution. And that would be our final answer. I hope this helped you out if you were still stuck. If not, please come talk to me.